In this lecture, we are going to look at an introduction into angles, rotations, and degree measures, as well as touch a little bit on some of the unit circle and radian measures. So first and foremost, when we're talking about angles, we have two different types of angles. We have positive and negative. And we do that by looking at where your rays are. So to begin with, we have our coordinate plane right here. And we essentially have our starting ray. So our starting ray is essentially your positive x-axis, so that's your starting ray. And then what happens is we have our rotation. So we've got this starting ray, or the initial side. Our rotation is going to be your angle. So let's say we rotated up. So the second ray here, this one, would be what's called your terminal side. It's your angle rotation. And when we look at the degree of rotation, we start at my x-axis and you're going to go up to your terminal angle, and we label that with our theta. Okay? Now, because this is going counterclockwise, this would be considered a positive angle. Now, the other one we have is we have negative. So we're still going to start with the same initial ray. So it's still going to be along this positive x-axis. But now let's say we're, down in this direction. So we've got our terminal side right here, and what happens is if we started with x and we rotate clockwise, this right here would be our angle, and this would be considered to be the negative angle. It's really important to pay attention to the direction of rotation so that you know exactly what it is that's going on. Okay? Now with that, we have our quadrants, and our quadrants are going to be labeled in very specific ways. So we're going to start here when our degree is 0. Okay, so when we're talking about just this initial starting line, or the x-axis, it's your degree is 0. Going in the counterclockwise direction, we go from 0 up to 90, from 90 to 180, 180 to 270. Now these are degrees. Now with this, in this first, going from 0 to 90, we call this quadrant 1. From 90 to 180 is quadrant 2. 180 to 270 is quadrant 3, and 270 to back to 0 would be quadrant 4. Now to go a full way around a circle, we call that 360 degrees. So what you'll notice is over here at this positive x-axis, you have two degree measures there. One is 0 because you're just starting out, or 360, you've gone a full circle around. Okay. Now we have a couple mathematical ideas that we use in relation to our degree measures. So first and foremost, we have your complete rotation is 360. Therefore, your half rotation is only 180. So if you start at 0 and you go half a circle, or if you start at 360 and go negative, then you have a quarter rotation is your 90 degree mark. Okay, so each one of these represents a 90 degree mark. Now, if your angle shares a terminal side, then it's called coterminal, and that occurs when we are talking about more than one angle together. But we have angle measures we look at. So again, first, a right angle is considered 90. An acute angle is any angle that measures between 0 and 90. So I like to remember it as acute little angle, meaning less than 90 degrees. Obtuse is going to be any angle that falls between 90 and 180. So we're talking about a large angle. I like to think of obtuse angle as like a lounge chair, okay, that I would go and sit in out in the sun. Now we also have a straight angle. A straight angle is exactly 180 degrees, okay, so it means that my terminal side would lie on the 180 degree line, whereas my initial side lies on 0. So neither one of them are going to show any movement off of the x-axis. Now we have two calculations that we do. First is complementary, the other is supplementary. Complementary says I'm going to take my two angles, I'm going to add them together, and I'm going to get 90 degrees as a result. So the sum is 90 degrees. Whereas my supplementary angle means I'm going to sum to 180 degrees. Okay? Now these two ideas are important when we are looking for additional angles based on, say, some given information. So don't forget these two as we move on. Now a unit circle is a circle where your center is at the origin and you have a radius of 1. So this definition right here is really important. What it means is that the distance from my center point here out to my outer edge, say out to this up here, would be a distance of 1. Okay, so here my radius going out to here, we would say that your radius equals 1. Now that being said, we also have coordinate points that we can look at. So again, here we would start at your center, so we could label this as the center, and it would be the coordinate point 0, 0. Well, that leads us to having 4 known coordinate points right off the bat, and they circle around. So first and foremost, we have your 0 degrees or your 360. And when we look at this first coordinate point, this would be at the coordinate point 1, 0. Okay, why? The distance from my center out here to the outer part of my circle is going to have a radius of 1. Now up at the top here we have 90 degrees. And again, going from center out to the edge of my circle, we would have the coordinate here at 0, 1. My third point is going to be over here at 180 degrees, which is the point -1, 0. Last, we have 270 degrees, which is the point 0, -1. Okay, so all of those are what helps to signify your unit circle. Now with this, because it's a unit circle, we can apply the circumference, which is c equals 2 pi r. Okay, now with your unit circle, we take this circumference and we can reduce it down to just 2 pi. And we know that because my radius is 1, therefore it's not affecting what's going on with the circumference of my circle. Now we are going to talk about radians. Okay, so radians are essentially degree measures in terms of pi. So that's really important to remember that here we are talking about measures in terms of pi. Okay, that's your radian. Now, 1 radian is the same as 57.3 degrees, so that's just kind of something you can keep in the back of your mind when working problems. However, we can label our circle in the same manner with radians as we did with degrees. Again, just like before, we would have your center, and our center is always going to be, at least in this case, you can consider it to be the point 0, 0. But now, if we're going to label this in terms of radians, we have two ways that we can do that. First would be in terms of pi measures. So we would start still at 0. 90 degrees is going to be pi over 2. 180 is pi. 270 is going to be 3 pi over 2. And then a full rotation is going to be 2 pi. Now the other way that we can look at radians is your decimals. So you would still start at 0, But then 90 degrees is going to be the decimal measure 1.57. Pi is the same as 3.14. 3 pi over 2 is going to be 4.71. And 2 pi is going to be the same as 6.28. Now, most of the time when we're talking about labeling or identifying our degrees on a circle or your radians on a circle, you're expected to have to know this information. This radian chart here, I highly suggest that you take some time and do your best to memorize it, as you will have to reference these ideas as you work with radian measures. Now, since we have two different measures, we have to be able to convert between both of them. So we have a method that we use to convert from degree to radian, and a method we use to go from radian to degree. So the first one, if we look at, we're going to go from degree measure to radian. So the biggest thing that we have to remember here is that we're going to take whatever measure we're given, and we are going to multiply by pi over 180. Now, the other piece that's really important with that is to remember when working with your calculator would be in radian mode. You would enter the angle and include the degree symbol. Okay? So, this is where you're really going to have to pay attention to a graphing calculator and make sure you're in the proper mode. Now, the other one is to go from radian to 2 degrees. So here again we are going to multiply your measure or your angle by 180 over pi. So notice with having pi in the denominator, what we're doing is we're going to cancel the pi out and leave the degrees. Again, with your calculator in degree mode, you're going to enter your angle measure and include the R symbol as your radian. Okay. Now, this little hint right here is probably the biggest hint I can give you when doing your conversions. Sometimes your angle measure may be given as a fraction. If that's the case, you need to make sure you use parentheses. Otherwise, what happens is the last digit that has been entered is considered to be the degree, and that's what gets converted. So you always want to make sure when using fractions that you use parentheses around that fraction. Alright, so that's a lot of information. So let's work some examples to make sure you understand kind of what's going on. So these first examples here are asking you to state the quadrant that the terminal side ends up in based on the measure you've been given. So what you have to remember about all three of these examples is that your initial side is going to be your positive x-axis. Now after that, you have to pay attention to the sign. So in this one, notice I have a negative sign. So that means I'm going to start at my initial and I'm going to rotate a negative direction. So I'm going to go counterclockwise. And I want to go 120 degrees. So one of the things that you can do for yourself, at least in the beginning, is get in the habit of labeling your quadrants. So here we would have 0, 90, 180, 270, and 360. Now here we want to go negative 120 degrees. So if we start at my 0 line and we come negative 90, that would bring us down here to 270. Then we want to go from that over just a little bit further. So here we would come over and it would tell you that your terminal side is going to end up right here. Now that being said, this would then be labeled as our negative 120 degrees. And the quadrant that our angle ended up in is going to be the third quadrant. Now here we have 1075 degrees. So with that being a really big number, one of the things that you would do is we need to recognize again that if we start at 0, we're going to end at 360. Again, this is 90, 180, 270. Okay. So what you're going to do is we're going to start and we're going to rotate. So we're going to start, and first we're going to go around, and when we go around once, this is 360 degrees. Then we're going to go around again, and you're going to have 720. We will then go around, or start going around again, but what you'd notice is that if we went all the way around, we would be at 1080. So instead, we're going to come around and be just shy of our line. So here, this would be my terminal side. This right here went 1075 degrees, and therefore my quadrant would be quadrant 4. Now for this one, notice we're in radians. And so again we have 0, we have pi over 2, we have pi, we have 3 pi over 2, and we have 2 pi. So in this case, notice I have 11 pi over 10. So there's a couple ways that you can do this. First, you can convert 11 pi over 10 over to its degree measure, and then use the degree reference in order to find out the quadrant you're in. Or you can use the exact same idea that we did kind of like with this second one here, only you would use it with your 90-degree quadrants. And what you would do is we would say, okay, if I went from 0 to pi over 2, then I would go from pi over 2 to pi, and we want to figure out where the 11 pi over 10 falls. Now, my advice would be convert to degrees when able. And the reason why I say when able is because sometimes you will come across problems where you have to leave things in radian measure. In this case, one of the things that you would look at is that nowhere does it say what we have to do. This is 11 pi over 10, which is roughly the same as 198 degrees. Now again, we get that by converting from radians into degrees. So in order to convert, we would take the 11 pi over 10, and we're going to multiply that by 180 over pi. When we go ahead and do that, we're going to come out with our degree measure. Okay, so that's the math that we're doing. So in this case, 198. So we would start here at 0. We would come up to 90, come over to 180, and come down to 198. And in this case, we did a positive measure, so we went in this direction, 198 degrees, which was the same as 11 pi over 10. Alright, another type of problem that you may be asked to do says to find two positive and two negative angles that are coterminal with the given angle. So what that essentially means is that you are given an angle measure and where it lands. So negative 81 degrees. So I want to find two positive angles that when I spin around my axis or my quadrants, I land in that same negative 81 degree space. Okay? So the easiest thing to do is to go ahead and figure out what is the positive equivalent to this negative 81 degrees. So you're going to take 360 and subtract away that 81 degrees, and what this does is it gives you the simulation that you have moved that negative degree measure. Okay? So again, remember, it's going to give us the illusion that we've started here at 360 and we're moving that negative 81 degrees down in this direction. And we want to figure out what this actually is had we rotated positive. So in doing that, we would come to find out that this is the same as 279 degrees. Now to find my second positive measure, I would take that 279 and I would add a full rotation to it. So we're going to take that 279 and we're going to spin it around once, and in this case we would then get 639 degrees would be the next degree measure. Okay, so if we want to look at what that looks like, so in this case we would have our quadrants. We would have that our measure is sitting right here. So this we spun at the negative 81 degrees. So what we did was we found out what happens if I rotate this, the positive. So then we went ahead and said, okay, now I'm going to go in the positive direction a full rotation. Okay, so that's what we did. In order to find negative, I would take my negative 81 degrees and I would go ahead and subtract a full rotation. In this case, we get negative 449 degrees. You would then do the same thing we did before. Take that negative 449 degrees, subtract another rotation, and that gives you a second negative degree measure. Okay? So again, if you want a visual on what's going on, we would have our same, here's the negative 81, so this is our original angle right here at negative 81 degrees. The first thing we did is we took that and we said, let's go a negative rotation. And then we did it one more time, a second negative rotation. And that gives you your coterminal angles. Now we can do that same idea with our radians. Okay, so here I would start with my radian, and in this case we're going to take our measure, so 7 pi over 12, and we're going to add 2 pi to it. When you do that, the first thing you get is going to be 31 pi over 12. You're going to then take what you found, so 31 pi over 12, add another rotation to it, and in this case you end up with 17 pi over 12. Now just like with the subtraction, we're going to do that same thing. We're still going to start with that 7 pi over 12, but this time we'll subtract a measure. And in doing that, we end up with a negative measure, so negative 17 pi over 12. We then take that negative 17 pi over 12, subtract another rotation, and thus negative 41 pi over 12. Okay, so those are coterminal angles, positive and negative, to the given angle that you have. Now we can also find the degree and the radian, complement and supplement angles by using the definition. So remember, when we're talking about complement, we are talking about summing to 90. So essentially what we do is we are looking at x plus your 47 degrees has to give you 90 degrees as a result. Therefore, your measure has to be 43 degrees. Okay, subtract away what you have, and that tells you what else you need. Your supplement is going to be where you sum to 180 degrees. Again, it's the same thing. Something plus my 47 degrees is going to be 180. Therefore, what I'm missing is 133 degrees. Again, by subtracting away the measure I know. We use the same idea with radians. So here, my complement is going to sum to pi over 2. So here we do the same thing. X plus pi over 8 has to give me pi over 2. Now, one of the things you're going to notice when working with radians is you do a lot with fractions. Okay? So in this case, what we would get is that we'd have pi over 2 minus the pi over 8. And in this case, you'll come out with 3 pi over 8. My biggest advice here is to leave it in terms of pi, otherwise you're working with a bunch of decimals and that tends to make things messy. Now my supplement is going to be the same, where we still sum to 180, but remember that was the same as pi. The math is identical. X plus my pi over 8 has to give me pi as a result. So again, we're looking at pi minus pi over 8, and that's going to give me my result of 7 pi over 8. Okay, the last few introductory examples I want to look at deal a little bit more with radians and conversions. So here we have determine the quadrant of the terminal side for the given angle. And notice these, there is nothing listed except for the number. So generally the rule of thumb is if you don't see the degree symbol, you can assume that you're dealing with radians. So this first one is a decimal. So remember those decimal measures: 0, 1.57, 3.14, 4.71, and 6.28. The decimal measures to our radians. And in this case, I want to go 1.8. So if I start with my initial side, so here my initial side is still going to be my x-axis. If I go up 90 degrees, I'm at 1.57. If I go all the way over, I'm at 3.14. So I'm going to be right about in here. So this from 0 to my terminal side is going to be my angle at 1.8, which says we are going to be in quadrant 2. Now the other measure is 47. So again, here is going to be my initial side. Again, I'm going to deal with my radians. So 0, 1.57, 3.14, 4.71, and a full rotation is 6.28. Okay. So one of the things that we have to do is figure out kind of how many times 47 is going around. The easiest thing to do is to take that 47 and subtract 6.28 and figure out how many times you can do that. Okay, so we would go ahead and you would just simply take, say, your calculator, and you would do 47 minus a full rotation. Okay, so let's go ahead. So if we start and we go minus a full rotation, here's one rotation, leaves you with 40.78 or 72, minus another rotation. Here's a second rotation, leaves you at 34, Subtract another one, so we're going to go another third. Here's a third rotation. Go a fourth rotation. Here's a fifth rotation. A sixth rotation. We'll go a seventh rotation. Lots of rotations. Now, what I want you to notice is when you go 7 rotations, you're left with 3.04. So when we're talking about your rotations here, you would have, 3.04. And so in this case, we would look at the fact that we've gone 7 full rotations and then part of one. So here we would then go over and around, and we would have our rotation. And so there we would have 47 is your angle, radians, and here we are in quadrant 2. Alright, the very last examples I wanted to look at here were conversion examples, just to make sure that we understand what conversions are. So here we have our conversions where we want to go from negative 214.6 degrees and convert over in terms of pi. So here we've got negative 214.6. To convert it, says we're going to multiply by pi over 180. When we do that, we are going to end up with negative 1.192 pi. And notice this one said to leave in terms of pi, so we want to make sure we leave the pi on the end. Okay. Now the second one says we're going to convert to the nearest hundredths. So the way this one's going to work is the same, 345 degrees times pi over 180 degrees. In this case though, we need to recall that pi is going to be 3.14. So what we're going to really do here is we're going to do 345 times 3.14 divided by 180. And in this case, we're going to end up with we're going to end up with 1.916 pi. Since I want the nearest hundredth, we could go ahead and multiply that out to give you 6.02. Now, the biggest thing that you want to make sure when you're going from degrees to radians is you need to change your calculator to radian mode. Okay, so you want to make sure you switch it over before you start doing your calculations. Now, if we convert to degrees, notice I have a radian here, so we would go 7 pi over 6, and we would multiply this by 180 degrees over pi. In this case, we would end up with 210 degrees, and your pi would go away. For these, you want to make sure that you change your calculator to degree mode. Okay. So there you have it. Everything that you would need to know about an introduction into angles and degrees and radians in terms of conversions and how all of that works. So if you have any questions, please let me know. Otherwise, I look forward to seeing you next time.